Hello students, welcome to EduCell. In this video, we are going to discuss about Karastova algorithm. This algorithm is a part of divide and conquer approach. We'll discuss why Karastova algorithm is introduced. Before that, what are the approach that we are following? That also we'll discuss. And one more thing I must say, Karastova algorithm is also known as integer multiplication algorithm using divide and conquer approach. So let us start the approach which we followed before while doing the multiplication. Okay, simple example I'm taking where there are two digits, like you can say 12 and 12 is getting multiplied. When we are multiplying this, so we know 2 is getting multiplied with 1 and 2. So in this category what we found, 2 is, if it is getting multiplied with 2, we got 4. Now it's 2. Then in this category, if I'll multiply with 2 with 1, we are getting 2 this side and 1 this side. And why this space? Because we shifted to 1, that's why we made a space. This is what we have already studied in our school level. Okay, the answer we got is 144 after multiplying these two different numbers, you can say. Okay, next we are doing the same thing, but we are just increasing one more digit we added, and total digits are now it's 3. Okay, so here 3 is getting multiplied with 3, we got 9, then 6, here is 3. Now for 2, it's 6, it's 4, it's 2 now. Next is 3, 2, here is 1. So the answer could be this is what the answer we are expecting while we will multiply these two numbers. Okay, here in Karastuba, we will be focusing on two different numbers are getting multiplied. When we are multiplying, we know these are the steps to be needed, and we are using algorithm means definitely we are focusing on complexities. Okay, let us take how do we find the complexity. We know if we'll add one more digit, we are taking time for it. Okay, so in case of complexity, time complexity, we are definitely increasing the time complexity if we'll add the digits. If you reduce the digits also, the same condition, the time complexity is reduced. Whether we are reducing the space or not, of course, yes, you are taking two lines for two digits, three lines for three digits. Definitely, we are enhancing the space. Not here. If you're calculating this thing using any array also, you will definitely take one more index for calculation, or definitely it depends on the number of indices. So whenever we are considering the array, okay, definitely it enhances the space also. These are the brute force method which we have already read. So the note we found here, if number of digits increases, I'm just writing this arrow, then you can say complexity, time complexity increases. Okay, so this arrow marks towards up means we enhanced the digits, means we are enhancing the complexity. So how do we found what the time complexity? You just think about it, like there are two different digits, that two with the two different numbers. So when we focus on these two digits, we know the digits are here are 4. You can say n is getting multiplied with n minus 1, or you can just simply focus on the number of digits. Here the number of digits are 4, here we have taken is 2, so it's all about 2 to the power 2. This is what we found as the number of uh, operations are being done. So here it is digits. Here in case there are uh, almost, yeah, there are 9 digits. So 9 digits, and here these are 3 digits. We know 3 square is 9. So we can say it is also digits. In simple word, what we are finding, if there are n number of digits, we know it's easy for us to find out if there are 2 digits, 3 digits, up to 4 digits, 5 digits also. We can do it. We can find the multiplication in easiest manner, not an issue. If there are, let us take, there are 100 number of digits or might be n number of digits, and how do we found like what is the time complexity for it? So in this case, we must write the time complexity depends on the n, which is nearly equal to n square in brute force approach, or what we studied in our school level. Okay, this is what our time complexity is if n number of digits are there. This is what we found in a brute force method, or you can say the school level method which we studied. Then Karasova introduced his own method to reduce the time complexity a little bit low to it. Okay. So first I'll write the steps for the Karasova algorithm. Then we'll follow the method. Then we'll find out the time complexity whether it is less than or not. This is the basic idea. When we started, we should know why we are reading the Karasova algorithm. Previously, we are getting n square while multiplying two different numbers having same digits each. Okay. Now, Karastova algorithm, I'm writing it. First, we'll decide what is f. Like we will be focusing on the number of digits. F stands for first number. A stands for second number. Then n stands for the number of bits. B stands for base. Base could be 10 or base could be 2. Here I must say I must write it or. Here base 10 means for digits, or base 2 for binary numbers. Okay. Here again I must write FL I am introducing, which is left hand side, portion of first number, and FR represents right hand side, portion of first number, SL represents the left hand side, portion of second number, and SR represents a right hand side of second number. Okay, this is what we have said it. like we just noted the thing to make the operation better or to reduce the complexity better. Now I'm writing the steps. Step 1, first we have to do left portion of the first digit or the first number will be multiplied with the left hand side of the second number. Step 2 is right hand side of the first number is multiplied with the right hand side of the second number. Step 3, FL plus FR into SL plus SR. Step 4, is step 3 minus step 2 minus step 1. Then step 5 is step 1 into b to the power n plus step 4 into b to the power n by 2 plus step 2. This is what our result is. Step 5 is our result. I must change that one. I must write it here. This is our result. Step 5 is our result. Clear? This is our result. We will get the result in step 5. But the approach, or you can say the algorithm steps, are being written in this way. First, left hand side and right hand side we have to segregate it. But we should mention the note even number of digits should be at both side of numbers or if no if odd digits, odd number of digits, then put 0 in front of digits. In front of digits. So that we'll discuss, but I am just writing the note. On the basis of this note, what we have to do is we have to run the steps first. It will run if the numbers which we have taken, uh, both the numbers have even number of digits. If odd, you put add you just add 0 in front of the number, because we know if 0 is getting added, no such value will be enhanced or decreased due to that. Okay, so just consider the same example. I'm just writing it. First number I'm just writing it as 12. Second number, now I'm writing it as 12 again. That we recently found the answers for 12 is 144. Now we are just running that same thing. Here I'm focusing this one as f of L. This is left hand side. This is left hand side of our second number. Now I'm changing the color for it. This is a right hand side of first number. This is a right hand side of second number. Okay. Now what we have to do is we have to simply follow the steps. For this step 1, we know FL into SL. Here FL is 1, SL is 1. So the answer is 1. Okay. So step 1, the answer is 1. Why? Because FL into SL. Now step 2, I am following the approach. Next FR into SR. The answer could be 2 into 2, which is 4. Because we have to first divide it. Why? Because it is divide and conquer approach. That's why we are following the divide approach to reduce the complexity. Okay. Now step 3. Step 3 is FL plus FR into SL plus SR. FL, the value will be like this, 3 into 3, which is 9. Okay. Step 4. As for the step 4, it is step 3 minus step 1 minus step 2. Okay. Two minus step 1. So as per this, the answer could be 9 minus step 2 is 4 minus 1, which is 4. Okay. Now the answer we are expecting as per the the formula which we studied recently, or you can say here as per the steps which we written for Karasu algorithm, is this one, step 3 minus step 2 minus step 1, which is 9 minus 5. I must write it clearly if you have any doubt. So 9 minus 5 is equivalent to 4. Now step 5, which is our result, it is like step 1 plus step 4, step 1 into b to the power n plus step 4 into b to the power n by 2 plus step 2. This is what our result should be. Clear? I must say in step 5, this is our result. Step 1, the answer is 1 that you got. But what is the value of b? Here I told you b is either 0, b is either 10 or 2. 2 if it is binary digits, 10 if it is a number. Clear? And n is the number of digits. The number of digits are 2 and the base is 10. I'm just writing the base is 10. Number of digits are 2 because here we found 12. 12 is 1 and 2, so 2 digits are there. Now you add step 1 in place of step 1, you just write the result of step 1, which is 1 into base is 10 and n, the number of digits you have taken is 2, so you write that one. Now in step 4, here the step 4, you write the result of step 4. Next 10, base is 10, n was 2 by 2 plus step 2 is 4. Next 100 plus 4 into 10 2 by 2 is this one plus 4. The answer could be 100 plus 40 plus 4 is 144. This is what the answer we got as the correct one. Okay. Next thing also you can add one more example. If first number is 12, second number is 2. I told you here the note it is written, if odd number of digits then put 0 in front of the numbers or in front of the digits of the number. Clear? So here in this example we know this is our example 2, this is our example 1. So here it is example 1 or Q1 I'm writing Q1. So it is better we write Q1. Here it is Q2. Okay. In this we have two numbers, but here the digits are, here n is 2, but here n is 1. That should be even always, you remember. If all are suppose here it is 1 2 3 in this case, so n would be 3, but here it is 1. So what we have to do, nearest even numbers we have to switch. Instead of 1 2 3 we have to write 0 1 2 3, and here we need to add 3 zeros to make it 4, because nearest numbers, nearest even digits will be selected. As for this, the nearest even digits will be expected as, because it's 2 now, and here it is 1, so we know 2 is even, so it is we will not change that one. We will just add 0 in front of it to make it even. To make it even, we are just putting 0 in front of it. So better I'll just change the color. I'm just making it green, and I'll write Y. Here I'm just writing we have added 0 to make the number of digits even. Digits even. Clear? So to make the number even, we have added 0 in front of it. Now you use the same method. So I'm just putting this color for left hand side of the first number. This is second hand, left hand side of the second number. Now this is right hand side of the first number. This is right hand side of the second number. Okay. Now you apply the steps. Step 1, you try to practice 2-3 times. Definitely you'll remember the steps. Left hand side of the first number will be multiplied with the second and left hand side of the second number. So which is 1 into 0, which is 0. Step 2, right hand side of the first number, right hand side of the second number. 2 cross 2 is 4 now. Step 3, left hand side of the first number plus right hand side of the first number getting multiplied with the left hand side of the second number plus right hand side of the second number, which is 1 plus 2 into 0 plus 2, which is 3 into 2 is 6. Clear? Next is step 4. In step 4, what we have to do is step 3 minus step 2 minus step 1. So the answers could be 6 minus 4 minus 0, which is 2. Now in step 5, which is our result step, basically the final step for us is step 1, getting multiplied with the base the digit, plus step 4, 4 into b to the power n by 2, plus step 2. Now in step 1, the result is 0 into base, as here we know the base is 10 and n is the number of digits, which are 2. Clear? Both should have same number of digits, then only it will apply, otherwise it will not getting applied. Okay. Next, 10 to the power 2 plus step 4 is 2 into 10 to the power 2 by 2 plus step 4 is 4. Now you do the simplification of it. 2 into 10 to the power 1 plus 4, which is 24. 24 is the answer that we know. 12 into 2. Small one, but that could be clearly being understood by us. That is why I have taken the example of it. Clear? So I have taken the same example. You can try with 1, 2, 3 into 1, 2, 3 by following the same approach, and you will definitely get 15,129 as we got here the answer. The same answer you will get it. You try by your own. Now, though we followed the step and we got the answer, next step is what should be the time complexity then? We will be discussing the time complexity. Though it's a recursion, as we know divide and conquer is following the recursion one. So from recursion we can operate on the recurrence relation to solve it. So I'm just changing the color to let you know, like it's a portion that we are actually dividing. When we are dividing, this is Tn by 2. Again this is Tn by 2. Again this portion is Tn by 2. The number of times we are operating on the each half of the number, that it takes that same division of time, like we divided the number into two halves because it's divide and conquer approach, and this is all about a combine approach. So this approach will take big of n. Combination we are doing, that we studied combinations. For combination purpose we are just using an array. Through that we are getting the recurrence relation will be as per the step 1. I'm just writing it. The recurrence relation as per the step 1. Step 1 plus step 2 plus step 3 plus step 4 plus step 5. The time complexity could be, it's Tn by 2, Tn by 2, Tn by 2. Step 4 is big of 1. Why? You can check it here. This is big of 1. We are just simply doing this simple calculation of it. That is why we are expecting the time complexity as a big of 1 time complexity. Next it is big of n. So as per the recurrence relation, T of n is 3T n by 2 plus big of n plus big of 1 or big of c. So we ignore that one and we simply remember the recurrence relation as 3Tn by 2 plus big of n. This is what we should remember. and this is our result. So the result should be here. I'm just writing T of n. I'm just adding this one, which is our result. Okay, the result will be this Tn. Now we will be following the approach, you can say a solution for it, whether we'll get the time complexity as little bit lower than this or not. So I'll be using the recursion one. Okay, iteration method, that could be better for recurrence, to solve the recurrence relation. I'm just using the method, you can say iteration method if it is being used. So T of n, first of all we have to write the answer of it, 3t n by 2 plus big of n, or you simply put it's n. Okay, now Tn by 2, the value of Tn by 2 will be 3, Tn by 4 plus n by 2. Again I'm telling those who are new, kindly watch the recurrence relation solution, how we are finding. So though Tn by 4 is new to us, so we are putting the value there in place of Tn by 2. So here for Tn by 4, whenever we are putting the value there, so it would be Tn by 8 plus n by 4. Now we will substitute the value one by one. Tn, this is our iteration method we are using. Next 3, in this Tn by 2 we are putting this value. So it is 3Tn by 4 plus n by 2 plus n. The answer could be 3 square T n by 4 plus 3 into n by 2 plus n. Now you can put the value here, so which you will be getting as 3 square 3t n by 8 plus n by 4 plus 3 into n by 2 plus n. Next it could be written as, or rewritten as, 3 cube. I'm just simplifying it in cube format. 3 square into n by 2 square plus 3 into n by 2 plus n. If I'm doing the same operation and I'm just doing the further simplification, I can write this as square into n plus 3 by 2 to the power 1 into n plus 3 by 2 to the power 0, because 0 it represents as 1. So 1 into n is n. So if I'm doing the same thing further, so this could be written as this format. So we can say run for k times. Run for k times. The answer could be T of n will be 3 to the power k T n by 2 to the power k plus it was 3 na? So the next will be 2, so it could be written as 3 to the power 3 by 2 to the power k minus 1, because it was previously 3, and the next one is 2, so k minus 1 n plus 3 to the power 2, it's k minus 2 n up to 3 to the power 2 to the power 0 into n. Now assume that we have reached the base condition. So in this base condition, we must write the base condition as T of 1 is equal to 1, where n value, if n value is equivalent to 1, so we are getting the base condition as 1. It is there. So whenever we are following this, digit, if digit is 1, we are simply putting the value as like 1 into 1 is 1, so 2 into 2 is 4. Like we will be having the base condition, and if it is greater than 1, then we will be following the condition of it. Now as per this, the base condition, we have to equate Tn by 2 to the power k equal to T of 1. Once we were equating with the result, means equating the cost there, we are getting n is 2 to the power k. And here, if n is 2 to the power k, to get the value of k, we are taking the logarithmic of it. Logarithmic based on the 2. Log base 2 is getting multiplied both the side. Log base 2, 2 to the power k. So here you should get the value as log n base 2 and k log 2 base 2 is 1. So I must write k value is equivalent to log n base 2. This is our value of k. Now what we have to do, we have to substitute the value in this equation. Suppose in first equation. Now you write substitute the value of k in equation 1. You will get T of n will be equivalent to 3 to the power k T n by 2 to the power k plus 3 by 2 k minus 1 into n plus 3 by 2 k to the power minus 2 n plus dot dot up to 3 0 into n. So here, when we will be putting the value, we should be doing one thing. We should be equating further. Okay. So if we're doing the further equation, I'm just I will be waiting for the substitution. The value will be substituted after it. So first we will be just deciding. We know in GP series 3 by 2 is greater than 1. So in GP series, what we have to do, n 2 to the power k. Now we are not substituting, we are just simply going for the GP series. As for the GP series, we know this is r for us. So in GP series, if r is greater than 1, so in that case 1 by r minus 1 will be the answer. Okay, and n will be multiplied if r is greater than 1. So I must write the answer now. 1 by 3 by 2 minus 1. 1 by r minus 1 if r is greater than 1. Okay, if r is greater than 1, so we must write this answer. Here r is 3 by 2. Here r is 3 by 2, which is greater than 1. That is why we are using this formula. Okay, T n by 2 to the power k. After equating this one, you will be getting 2 there. I'm again simplifying it. So 3 to the power k will be here n by 2 to the power k. It is equated to the base condition. Why? Because you can check this one, n equal to 2 to the power k. I'm just writing n by n plus 2n. If I further substituting this value, like if I further simplifying this value, I'll be getting 2n. Now this n getting cancelled, k, t of 1 plus 2n. So t of 1 is 1. So the answer will be 3 to the power k plus 2n. Now you substitute the value of k. 3 will be log k value is base to 2n. So how do we know? Then we know there is a log formula can run where they can be interchanged. Okay. So n log 3 base 2 plus 2 into n. So in this case we know n to the power 1.59 plus 2 into n to the power 1. So we know the maximum complexity if I consider, so it could be big of n to the power 1.59. This is what our time complexity is, the maximum time complexity we are expecting or we are getting. Time complexity. Okay. So we know big of n, big of n to the power 1.59 is definitely less than big of n square. We are getting this answer using brute force method. But this time complexity we are getting due to Karatsuba. Using divide and conquer approach. Okay, so that is why in general the questions are being asked the integer multiplication using division, divide and conquer approach, whether we are getting the less time complexity or not. If yes, then how? This is how we are getting the complexity as less. But one more thing we should remember, we have to work on the Karstuba algorithm must work on must work on even number of digits present in a number. This is must. If not, you please change that to 0. You add 0 in front of the numbers which are being there, like we discussed recently. We're taking another example. So this is what the target is. We are getting somehow less than the brute force method. That is why it is widely accepted by the researchers. I hope it is clearly understood to you. So if any doubt, please comment below. Thank you. Have a good day.